We have already covered dictionaries in Python. Let's now see sets and see what's so unique about sets. Sets, similar to the sets you studied in math, they store collection of data. But what is the difference between sets and other structures? Items must be unique. You cannot have duplicate items in a set. This is one. Set is unordered. There is no order in sets. In lists, the index is the order. In dictionaries, the key is the what you search for or the order. And elements can be of different types. So in sets, you cannot have duplicate items. Sets are unordered. There is no way to search by an order. And you can have elements of any type. So how to create a set? Very similar to other structures. You just call set. And this one will call an empty set. Most of the time, 90% of the time, you will create sets from existing structures, like from list or other things, or files, or. If the set is unempty, or you have some data that you want to put in a set, you can say set and something argument here. However, the argument must contain some kind of iterable elements. So let me show you this in an example. Here, if you say set A, B, C, see the A is available twice. What will be put in the set is one of each of them, no duplicates. So the letter A is only available once in the set. Maybe you thought the word itself will be put in the set, but no. If you have words, there is another way to do it. But now, if you provide a string, imagine what's going to have if you do 4 character in a string. If you do 4 character in a string, you'll get 1 character at a time. If you add them to the list, they all are added to the list. But in the set, they are added, but duplicates are removed. Let's see this in action. Here is create our first program, set 1.python. Set or S is equal to set of A, B, B, C, C, D, E, F. What's going to happen is, let's just add equal here. What's going to happen is it will take only one character from this string and put it in the set. Let me print S here, run, and look at the contents of the set here, one each. If you want to put a string, this is another thing. You need to put the strings in a list, and the list will be iterable. But now this is one string, and the characters are the iterables, so one of each character will be put in the set. Let us see if you want to put, for example, S2 is equal set of another string with digits this time and some letters, and let us print S2 and the same result we get here. S1, sorry, I called it. Run. So you see only one of the items, no duplicates and no order. Very important, no order. If you want to create a set of strings, you pass them as a list. This is an error. This is not an iterable thing. Here is the way how to do a set of lists. You say set and then you give it a list of items. This one will work, but the other way is not going to work. So remember, you cannot just give strings separated by commas. You need to provide a list of strings. And this is easy in Python. Let's see this in code. So if I try to create here, S2 is equal set of A, comma, B, comma, C, or anything like this. Let's see the code here. If we run it, we get an error. Type error. Set expected at the most one argument. So only one argument. You cannot separate them by commas. So the best way is to give these arguments in a list, and that's it. Now it works. Let me print S2, and now ABC, ABCam are members of the set. So similar to other things you learned in Python, how many elements in the set? You use the len function. How to add? You use add. Very simple. So how to know the length? Len. How to add? Add. Here if I say print len of S2, run, I get 3 as length of S2. Let me add something. S2 dot add anything you can add, test, and I will print S2 again after adding. So test has been added. If you ask me why it is in the beginning or the end, I don't know. Order doesn't matter in sets. Membership is what matters. In the set or not in the set. Order is not part of this. If you need order and other things, you can use lists. Add will help you add one item to the set. However, update is very useful. You can add a group of elements, not only one element, to the set. Again, argument must be sequence containing iterable elements, and each element is added to the set. Look at this. X is equal to this much. Update. Oh, a new list here. Multiple items. So what happens is all the items are added to the list. The question is, what if we have duplicates? Duplicates are ignored. So look at the output here. Let's update it again. X.update print X. But did you notice something here that Y is equals a new set, update Y. Here we gave the name of the set or the list, sorry. Let's see this in code. So I have already set to, I can say s2.update. I'll give it a list, okay? Any data type is fine, data, list. So 3 items should be added to S2, print S2. Let's see the output after we update S2 now. All of them added to the set. Let me add all items in another set directly. For example, here, S2.update S1. S1 contains some letters. Let us just make it smaller. So here I gave a list name and here I gave a list contents directly. Let me print S2 and see the output. Here we see some items from the other list. Let's do something here. Instead of K, I will do CAM. CAM is already available in S2. And I am providing a new list with CAM again. Are we going to see two CAMs? No. Only one because duplicate items are ignored. Deleting an element from a set. We have two methods that can be used to delete an element from the set, either remove and discard. And we will talk to you about the difference. Here we have a set. Remove 3, print X. As you see, this is removed. No 3 in the set. Good. Let's see this. I will simplify the code here, just like this. I will say s2 dot remove and remove cam. Then I will say print s2 again. Run. So cam has been removed from S2. Test was added somewhere here on line 5. Now, what if cam or something you're trying to remove is not there? Okay, let me say cam, not cam. This thing does not exist in the set. And we are using remove. Run, we get an error. Key error. There is no cam in the list. So what's the difference between now remove and discard? Let me use discard. Instead of remove, let me use discard. Discard does not generate an error. The program continues. That's it. Run. So discard, the cam is not there, but there is no error as you see here in remove. Of course, discard will remove the item if it exists. It works exactly like remove. However, if the item does not exist, it does not generate an error and the program continues. So it's up to you. It depends on the problem you're trying to solve. You want to handle this error or not, or just ignore it. It depends on the problem itself, which one to use. Let's clear some space here. If you want to clear all elements from the set, s2 dot clear. Clear removes all elements from the set. Let us print it. After that, run. So clear here, line 7. Now I am printing the set and the set is empty. So to remove one element, you have remove or discard. Discard does not generate an error if the item is not in the set. To clear all elements and make the set empty again, you use clear. This is very useful. Sometimes you are in a loop and you need to clear the set. Every time you can use clear. Can we use for loop to iterate through elements of a set? Definitely. You can do this. Here we have S2, 4, I in S2. Print I. That's it. There is no order here. Okay? You cannot go by index, tamam? See? I don't guarantee the order. Cam A, B. So very simple. You can use it like any other structure you have used before. What about in and not in? Are they available in sets? Yes, they are, and they are very, very helpful. They return either true or false to use in and not in. Here, we can say print, for example, K in S2, we will get false. As you see here, print A in S2, we get true. Not in, A not in S2, actually A is in S2, you get false. K not in S2, K is not, so you get true for this expression. So you can use a for loop to iterate over the elements of the set. You can use in and not in. Sets operations. Now back to your elementary school or middle school. When you studied sets operations, union, intersection, difference, and all other these things. So union of two sets is set 1 plus set 2. The thing that any duplicates are going to be ignored. Here we see set x, set y, union will give you the elements. However, 5 is available in both of them. In the result set, which is z, x union y, you will get only 1 5, not 2 5s. This output is for something else. Here, we do union, but we are using the union operator, which is a vertical bar. Yani you can use set dot union set 2 or set 1 vertical bar set 2. Let's see this. Let me create another set. S3 is equal to set. I'll make a list. Here is a duplicate. Here's 1. Here's 9. Here is test. So we have two sets. Let's make a union of them. I can say Z is equal S2 union S3. So union will put all elements from the two sets, but one occurrence only for duplicate items. Let's see this. Look at this. 1A test can be 9. A has not been duplicated. Let us do more things here. Let me add 1 and 9 also in the first set. And we are getting the same output. 1 and 9 test, only one thing. Is this the only way how to do union? No. Look at this. S2, vertical bar, S3. This is another way of doing union. Same answer. Intersection. Intersection of two sets is the set that contains elements found on both, yani common elements in both sets. How to do it? Set 1 intersection of set 2. Or you can use this simple ampersand to find the intersection. Go back to the same code. Here, I'll just change one thing here. And so now Z will be the intersection of S2 and S3, which is, I believe, A19. Let's see the output. Yes, 19 and A. These are the common elements between the two sets. You can use ampersand, or you can just type dot intersection of S3. You get the same answer. So we have seen union and intersection. Difference. Difference of two sets is a set that contains elements that appear in the first but do not appear in the second. So this time you need to pay attention to which set is first and which set is second. Things that are in one but not in the other. Things that are in the first but not in the second. Here is the method, and you can also use the minus operator. In the first but not in the second. Let's do it. Here I have two sets. I can type difference. So what things are in the first but not in the second? Cam and B, I believe. Let's see. Yes, B and cam. Minus sign can also be used here. S3. Run B and cam. Let's change it. Make it S3 minus S2. Now S3 is the first. So the question will be things that are in the second in S3 but not in S2. It seems like only test maybe, so right here we see test only. So this is in difference. Let's see symmetric difference now. Symmetric difference of two sets is a set that contains the elements that are not shared. What do we mean by not shared? Not shared means in the first but not in the second, and in the second but not in the first. And the opposite of intersection. To find symmetric difference, we use symmetric difference method. Or we can use this cap symbol. Let's see this now. I'll use the symbol directly here. Things that are in the first but not in the second, and things that are in the second but not in the first. In the first, I know B and cam. In the second, only test is not common. Let's run this. So cam test B. Things that are in the first but not in the seconds, plus things that are in the seconds but not in the first. Of course, you can also use here symmetric difference if you don't want to use the symbol. So this is the symmetric difference. Superset and subset. These methods return true or false. As you recall, most of the methods that start with is usually return true or false. So is subset and is superset. Let's explain them in the examples. Let's just do this here. Print S2 is subset of S3. Is subset will return true if all the elements of S2 are in S3, and definitely here it's false because there are elements in S2 that are not in S3. If I remove cam and B, I believe now S2 is subset of S3. Let's see this. I get true because all elements of S2 are available in S3. Superset is the opposite. All elements of one are included in another. Now, S3 actually is a superset of S2. It contains all elements of S2 plus other things. So let's see here. Is subset S3 is not subset, of course, because S3. طب is S3 a superset? Yes. Sorry, let me change it here. Is superset, not subset. Because S3 contains all the elements of S2 plus other elements. Again, I typed by mistake. I did it 3 times maybe by mistake. Is superset, not subset, superset. Yes, the answer is true. Subset, all elements of S2 are included in S3. Superset, all elements of S2 are in S3 and S3 still has other elements. For subset, you can use less than or equal. This is much easier than. And for superset, you can use greater than or equal. Let's see this in code. S3 greater than or equal S2. The answer is true here because it's a superset. If you want to check for subset, use less than or equal, not greater than. This is false now.